Alright guys, welcome back. So I wanted to show you a quick little project that I just finished. This was a tool that I made. It's based on the KTM part that allows you or helps you to properly measure the top dead center of a piston when you're rebuilding an engine. So the way this device works is that you would put an indicator on there. You get that inside there. You would put this over top of your cylinder, and when the piston comes up at top dead center, after you've calibrated this, of course, it tells you how low the piston is relative to the top of the cylinder. A very useful tool if you want to do things accurately, so you can figure out your gasket sizes and all that. So anyway, of course I didn't make the dial indicator, but this is the base right here. And I'm not too sure what kind of steel this is, so not the right key. But I'm going to heat treat it anyway, just to see if I can harden it. It's some unknown steel that I had, a big chunk of it. So to make this, what I've done, I've taken a chunk of steel like this. I have a bunch of these short end pieces, chucked it up in the lathe and made this part. Then I took a chunk of aluminum and made this bushing because brass, well, you know, normally you do it out of brass, but brass is hard to come by, it's expensive, and I don't feel like machining a big chunk of brass just to get a little bushing out of it. I have lots of aluminum, and as long as I make it a little bigger and take into account the springiness of it, or the brittleness of the aluminum, this sleeve should work fine. So the way I've built this is I've bored a hole in the middle that's oversized to take, it's actually 14 millimeters, to take this bushing. And once I made this bushing, I bored that bushing to, I think, 9.5 millimeters for the shafts of these dial indicators. And that fits very nicely over top of that, and the idea is that a grub screw will clamp down on this and keep the body of the dial indicator from moving around, and without marring it as well too. So what I've had to do with the aluminum after I slotted it is I had to because it's a 2 millimeters thick wall. So what I did, I ended up slotting the opposite side to give the the bushing a little more give when a grub screw is on there, because without it, it was a little too stiff. So yeah, just a little V notch right there across the back side of the actual notch helped give it just enough springiness. And so that, yeah, goes in like so. And you just got to make sure that it doesn't protrude out of the bottom. So that's what that looks like at the bottom. And then there's then I threaded a 1/4 inch grub screw, and that fits in there like that. And then after that, you just drop your indicator on top and tighten down on the grub screw like so, and that is on there solid. It is not moving. And so on the business end of it here, you can see where the indicator actually sticks out a little bit. So when the piston comes up when you're moving it, to find top, and the of course this part of the tool sits on the top of the cylinder, so when the piston comes up at top dead center, it pushes down on the indicator, and then you can see, because you've already set the indicator to 0 on a granite plate, you can see how far down that piston is at top dead center, and then figure out your gasket height. So nice simple little tool. Did a great job. I was able to figure out my gasket height quite nicely. So yeah, so that's that. I'm going to heat treat this next, and then after that I'm going to, depending on the color of it and what it looks like, I'm going to blue it. So this is just the first part.